Hello students, welcome to my channel Nikita's Math Academy. We are solving part B of exercise 1.1. Question 4. Use Euclid's division lemma to show that the square of any positive integer is of the form 3m or 3m plus 1 for some integer m. What we have to do, students, here we have to show that square of any positive integer is of the form 3m or 3m plus 1. So let me tell you how you have to start this. What we'll do, we'll take that a be any positive integer. Let a be any positive integer, and let's take b as another integer which is equals to 3, and b equals to 3 as some another positive integer. Then what we will do, we will use Euclid's division lemma. So using Euclid's division lemma on a and b, so we are going to use Euclid's division lemma on a and b whose value equal is 3, then we have a equals to dq plus r, right? Where r is greater than equals to 0 and less than q less than b, right? Now students, we are having value of b as 3, so this will become a equals to 3q plus r, where value of r will be greater than equals to 0 and less than 3. What does this imply? This implies that value of r is 0, 1 or 2. Now what we are going to do, students, we have to use all these cases. That is case number 1, and value of r equals to 0. In that case, we'll get a equals to 3q. Now students, we have to show square of this number as 3m. So what we will do, we'll take square of this. That is a square equals to 3q squared. Now after solving, we are getting a square equals to 9q square. Now students, this can be written as a square equals to 3 into 3q square, right? What we will do in next step, we'll put 3q square as m, and we are having a square equals to 3m. Now let's take case number 2, when the value of r is 1. So we are having a equals to 3q plus 1. Let's take their square, a square 3q plus 1 whole square. So this will be a square equals to 9q square plus 6q plus 1. We have used a plus b whole square formula. Now a square will be equals to, we are taking 3 as common, then we are having 3q square plus 2q plus 1. What we'll do here, students, we'll put this 3q square plus 2q equals to m. Then we are having a square equals to 3m plus 1, right? Now the last case, when value of r is 2. So we are having third case as a equals to 3q plus 2, right? Let's do the same thing. We are squaring on both sides, right? So we are having a square equals to, this will be 9q square. This will be 12q plus 4, right? Now students, what we can do, we can write 4 as 3 plus 1, right? We can write it as 3 plus 1. So what we will do in the next step, here we will take 3 as common. So in bracket we will be having 3q square plus 4q plus 1 plus 1, right? Here what I'll do, I'll put this bracket, that is 3q square plus 4q plus 1 equals to m. Then I am getting a square equals to 3m plus 1. So students, here you can see in all the cases. In first case, we got a square equals to 3m. In second case, we got a square equals to 3m plus 1. And in third square also, we got a square equals to 3m plus 1. Hence, we proved that sum of any positive integer is of the form 3m or 3m plus 1 for some integer m. Now let's solve another question. Just a second, students. Now, this is similar type of question, students. We have to use Euclid's division lemma to show that cube of any positive integers is of the form 9m plus 1 or 9m plus 8. So we'll start with the similar steps. So let A be any positive integer and let B be another positive integer with value as 3. Okay, you will understand why I have taken B equals to 3. Now, what we are going to do, we have to use Euclid's division lemma. So, using Euclid's division lemma, on which two numbers we are going to use this lemma? On A and B. Using Euclid's division lemma on A and B, where value of B is 3, we have A equals to B cube plus R, where value of R is greater than equals to 0 and less than B, right? But we are having value of B as 3, so it will be 3 cube plus R, where value of R greater than equals to 0 and less than 3. Again, this is giving us three cases when R equals to 0, 1, and 2. So we will use the same method, students, as I told you earlier. First case, when R equals to 0, so we are having A equals to 3 cube. Here we have to show their cubes, right? So we will take king cube on both sides. So it will be A cube 3 cube whole cube. So we will be getting A cube equals to 27 q cube. The 27 q cube can be written as 9 into 3 q cube, right? What we will do here, we'll put 3 q cube equals to m. So we are having A cube equals to 9m. Okay, now let's take next case. That is when R equals to 1. So we'll be having A equals to 3q plus 1, right? Taking cube on both sides. So 3q plus 1 whole cube. Now students, here we need to use A plus B whole cube formula. I hope everyone remembers the formula. So this will be 27 q cube plus 3 3 a square b. So this will be 27 q square plus 9q plus 1, right? And what is the formula for A plus B whole cube? It is A cube plus 3a square b plus 3ab square plus b cube, right? So we have used this formula here. Now, what we have to do in the next step? We'll take 9 as common, right? So we are having 3q cube plus 3q square plus q plus 1. Now, can you tell me what will be our next step? Yes, correct. We'll put this bracket. So that is 3q cube plus 3q square plus q equals to m. This implies a cube equals to 9m plus 1. One more case is left when r equals to 2. So a equals to 3q plus 2, right? Now, what will be the next step? Yes, we need to take their cube. So it will be a cube 3q plus 2 whole cube. Okay, so it will be a cube. We need to use this formula. So this will be 27 q cube plus 54q plus 36q plus 8, right? Students, please check whether it is correct or not. Okay. Now, what we'll do in the next step? We'll again take 9 as common. So this will be 3q cube plus 6q plus 4q plus, now this will be 54q square, right? Plus, the bracket will be closed and this will be plus 8, right? Now, can you tell me what will be our next step? Very good. We'll need to put 3q cube plus 6q square plus 4q equals to m. Then we got a cube equals to 9m plus 8. Now, students, observe this. In the first case, In the first case, we got a cube equals to 9m. The second case, we got a cube equals to 9m plus 1. And in the third case, we got a cube equals to 9m plus 8. Hence, we show that the cube of any positive integer is of the form 9m, 9m plus 1, or 9m plus 8. Students, this ends our exercise 1.1. Now, thank you for watching.